of civilization, like basically maximize the probability that civilization has a great future.
You felt the change in your own life. Everything that matters now rides on a signal. Your phone, your bank login, your work files. Lose the connection and you feel blind. That dependency is the problem Elon Musk keeps circling. Machines can get smarter, robots can get stronger, but none of it works without a fast, steady link. In the past, these pieces were separate. One company made the car, another made the phone, a third made the satellite. By 2030, that split is the problem. It slows the whole machine down. The moves since 2025 point one way. They point to convergence. They point to one joined system: data, AI, network, robots, and space transport. One stack, end to end. If that stack works, it changes what scale even means. Start with the wall the industry is trying to climb. AI needs power, not just a lot. It needs steady power all day. It also needs fast data, real-time data, not old files. It needs a network that reaches everywhere. On Earth, those needs clash. Cities fight data centers. Grids hit limits. Land costs climb. Bigger AI wants a bigger footprint. People push back. That tension is the wall. Now look at the first phase. The idea is simple on paper. Put data and AI under one roof. The merger of xAI and the social platform X was about real-time behavior data. That matters because training needs fresh signals. Not just books, not just old posts, actual live behavior. Real-time data can steer what the model learns next. It can also show what people ask for right now. Here comes the first reveal. The convergence story starts with data flow, not rockets. If you own the data stream, you can tune the AI faster. The prompt calls out Grok as the model writing that stream. The bet is that the model learns from the real world as it happens. That is a different posture than slow batch updates. Think about that for a second. 500 million posts hit the platform every day. You feel that pace in your gut. You scroll. The feed moves. News breaks there first. Jokes land there first. And after the integration, that stream feeds straight into the model. No middleman, no wait, just raw words right now. You felt the lag elsewhere. You ask a question. The answer sounds yesterday. It feels clean but thin. You were right to notice. Freshness matters. Timing matters. If a system sees the world late, it thinks late. That gap is the whole story here. The system drinks from a fire hose. Others don't own a fire hose at all. They rely on crawls. They rely on deals. All of those add delay. Delay costs insight, but data needs a path. That leads directly to the network piece. The network is not rented, it is owned. Starlink shares connectivity across the empire. If Starlink becomes the backbone, then the AI is not stuck behind other carriers. It can move data across the planet. It can reach ships, deserts, and remote job sites. That matters for robotics and cars. It also matters for space operations later. Now pin the date that tightens everything. February 2026. A formal merger happens. That is a pivot point. It suggests the first phase ends with a new legal structure. That is when the talk becomes a single company move, not a handshake. That is also when the plan for orbital AI data centers becomes enabled, solar-powered. In orbit, that phrase is the big swing. Here comes the second reveal. The plan links orbital centers to big battery boxes. They store power. They smooth power. The idea is simple. Solar gives you power when the sun hits. Batteries help you keep it stable. Stable power feeds computers. Computers feed AI. That loop is the backbone of the whole plan. This is also where the previous failures show up. Not in a crash video. In the slow grind, the old model is scattered. Data here, chips there, power somewhere else. That split creates delays. It creates fights over who pays. It creates gaps in timing. You've seen big tech roadmaps slip for that reason. People call it coordination. It is really friction. The breakthrough is the consolidation itself, not one magic chip, not one new rocket part. The innovation is the stack. One owner can force the parts to move together. That is the method. Merge the AI with the data stream, tie it to the network, then push it into machines that operate in the real world. That is how you turn model demos into results. Now move into the next phase, physical integration. This is where software has to prove itself in metal. The plan says Starlink becomes the nervous system. That wording matters. It implies constant signals. It implies always-on links. If Starlink is the nervous system, then robots and cars become the muscles, and the AI becomes the brain. Here is the first near-miss moment. Picture a rollout day. One engineer tries to connect a new robotics fleet. The link stutters, the model lags. A small delay ruins control. That is 30 seconds from a public failure. The system has to recover. It has to route around the gap. That is where real engineering lives, not in the keynote. In the recovery, the prompt says production ramps up for the robot, Optimus. It also says Optimus uses the same batteries, motors, and AI chips as vehicles. That is resource efficiency. One parts bin feeds 2 product lines. That cuts cost. It also speeds learning. A robot and a car can share lessons. Now connect the AI back into motion. The integration allows the model to integrate into vehicles for self-driving and robot training. That is technical system mastery. Self-driving is not a toy. It is a control problem. It needs perception, planning, and quick reaction. Feeding it better AI and better data could move the needle. Here comes the third reveal. Orbital AI centers powered by solar become part of the plan. Solar in orbit means long sun exposure. It means fewer local fights. It means no land grab. It also means a new kind of scale. If your compute sits above Earth, the grid limit changes. The bottleneck shifts from getting power to launching it, and that is where Starship enters as a system tool. The massive rocket launches robots to the Moon and Mars. That is strategic future positioning. It tells you this is not just about serving Earth markets. It points to Earth to Mars operations, a network, a brain, and machines, all across distance. Now hit the competitive assessment. Most companies can build software, some can build cars, few can build rockets, fewer still can build a global satellite network. The convergence bet is that no rival owns all layers. They might match one layer, they might even lead it. But the stack advantage compounds when the pieces interlock. Now pivot back to momentum. The nervous system concept scales beyond Earth. A planetary network. That phrase matters. It implies that Starlink is not just for Earth customers. It becomes the comm layer for remote robots. It also becomes the comm layer for space missions. This is a big claim. It also fits the Mars frame. Now move to phase 3, human-machine unity. The centerpiece here is Neuralink. The plan says Neuralink scales implants for brain control. It even gives an example. Think to summon a car. That is not a small step. That is a new interface layer. This is where the impossible word fits, but not at the start. A brain link at scale feels impossible to many people. The reason is technical and human. The brain is noisy. Biology varies. Safety standards are strict. Trust is hard. That is the wall here. You can't brute force it with money. You need careful work step by step. Here comes the fourth reveal. The implant becomes an interface across the ecosystem, not just a medical device. An input method. If that happens, then the stack becomes more than machines and screens. It becomes direct intent. That is a different kind of control loop. It also creates new value. The person becomes part of the network. Now the plan goes even further. It says full convergence leads to a unified mind across platforms. That name is a signal. It implies one brain across platforms. It implies shared memory and shared goals across cars, robots, space transport, and the network. That is massive. It is also risky if mishandled. So the only way it works is control and guardrails. This is where the third near-miss moment fits. One engineer tries to run a unified model across a car and a robot. The car sees a hazard. The robot sees a different task. The model has to separate contexts. If it blends them, it fails. That is 30 seconds from a dangerous error. The test has to prove isolation. It has to prove reliability. This is not drama, it is basic system safety. Now deliver the method in plain terms. Data comes from the social platform. AI models run in the dedicated AI company. The network comes from Starlink. Machines come from Tesla cars and Optimus robots. Space transport comes from SpaceX and Starship. The interface layer comes from Neuralink. That is the stack. The key is that each layer feeds the next, and each layer produces more data for the first. Here is the pattern recognition with 3 examples. First, mergers reduce delay and conflict. Second, tech sharing reuses parts like batteries and motors. Third, shared networks let the same AI control many machines. These 3 patterns are the strategy. They point to one goal: faster loops, faster learning, faster deployment. Now place the competitive scoreboard with numbers. The full plan runs across 3 phases. The first phase sets data and AI. The second ties AI to machines in the network. The third adds humans into the control loop. That is a 6-year runway to 2030. In business terms, that is short. In aerospace terms, it is lightning. That speed itself is the contest. Now validate victory with metrics. You have timelines. You have billions invested. You have the 2030 target. You have named systems like Starlink, Grok, Optimus, Starship, and Neuralink. The measurable proof points are whether those name systems actually integrate, not whether they exist. They already exist as brands and programs. The score is integration. The Earth to Mars operations frame is not just a slogan. A Mars operation needs 3 things non-stop: communication, power, and automation. Starlink-like networks handle comm. Orbital solar compute hints at power and brains. Robots handle labor. If you want Mars scale, you need those anyway. Convergence makes the Mars stack also pay off on Earth. The power shift from ground to orbit is critical. Orbital solar AI centers change where compute lives. If compute moves up, then the bottleneck becomes launch cadence and satellite build rate. That puts the advantage back into the aerospace side of the stack. It also ties AI growth to rocket production, not local grids. The interface layer makes the whole system more personal. Neuralink scaling implies direct control and direct feedback. In plain terms, it means intent becomes a signal. Signal becomes command. Command becomes action. Action becomes new data. Data feeds the AI. That closes the loop. A tight loop is what makes systems feel alive. The brand consolidation suggests a single name for a single brain. That can pull customers across products. It can also pull developers. It becomes a platform, not a gadget. Platforms win when they set the rules. Now address the pain point you carry and resolve it. The fear is that this is just talk. You've been burned by big talk before. You've seen timelines slip. The prompt itself admits the step list is not official in public. That could feel like smoke, but the resolution is in the moves. Mergers, investments, and tech sharing are costly to reverse. Once you merge, you restructure teams, you move budgets, you commit leaders. That is not free. That is commitment you can measure. The merge did not start with money. It started with power. AI eats power. AI also makes heat. You already know both are a problem. You see power bills climb. You see data centers fight neighbors. You see cooling limits stall growth. That wall keeps showing up. In February 2026, the move went straight at it. The merger of XAI into SpaceX was not subtle. Space has power. Space has cooling. Space has room. SpaceX already owns the path there. You felt this coming. You see AI grow fast. You see grid strain. You see cooling limits hit first. This move fits that picture. The models need huge compute. Huge compute needs power and cooling. Earth is running out of both in the right places. That pressure explains the timing. February 2026 was not random. It lined up with Starship progress and Starlink scale. Here's the reveal. SpaceX already controls the physical layer. Rockets move hardware. Starlink satellites move data. Solar arrays make power. Radiative panels dump heat. XAI brings models and data. Put together, that stack runs end to end. No landlord, no grid gatekeeper, no water permit. That is the real reason for the merge. The second reveal is control. SpaceX did not buy XAI. SpaceX absorbed it. That tells you who sits at the center. That matters. It puts AI under the same command chain as rockets and satellites. Decisions get faster. Trade-offs get cleaner. The physical limits drive the software roadmap, not the other way around. Now the third reveal lands. This move came ahead of a planned IPO. The target value floated was about 1.25 trillion. That number signals scale. It also signals confidence in integration. Markets reward control of the full stack. SpaceX with XAI and Starlink is not a bundle. It is a machine. Inputs go in. Compute and data come out. The problem this solves is simple. Earth-based AI demands unsustainable power. Data centers already pull massive energy. Cooling burns water. Grids take years to upgrade. Those delays kill growth. Space-based AI flips that script. Solar power runs in constant sunlight. Cooling radiates heat into vacuum. That removes two hard caps at once. Here is where the plan gets specific. SpaceX intends to launch AI satellites quickly. These are not phones in space. These are compute nodes. Think GPU clusters packaged into satellites. Some may be modular, some may link together. Starship lifts them. Starlink connects them. Solar arrays power them. Radiative panels cool them. You already know why Starship matters here. Cargo is how much stuff it carries. Starship aims for over 100 tons per flight. That is not a tweak. That is a jump. Older rockets send small batches. Starship sends truckloads. That makes orbit data centers possible at all. Without that lift, this stays a dream. Previous attempts failed for clear reasons. Launch costs stayed high. Payload stayed small. Cooling in space looked hard. Power looked limited. Those failures taught the lesson. You cannot bolt AI onto old launch systems. You need a new baseline. Starship resets that baseline. Reuse drops cost per flight. Size cuts assembly steps. Now the breakthrough is not one trick. It is the stack. Rockets deploy hardware. Satellites host compute. Solar arrays supply steady power. Radiative panels shed heat. Optical links move data. Starlink ties it all together. Each piece existed before. No one owned all of them at once. SpaceX now does. Think about the heat problem again. Chips get hot. On Earth, fans and water move heat away. In space, there is no air. So SpaceX uses radiative cooling. Hot panels glow heat away as light. The prompt gives a hard sizing clue, about 3 meters by 3 meters of panel per 10 kilowatts of compute. That sets design rules. It forces discipline. This is where one near miss matters. Early designs likely push density too far. Heat builds faster than panels dump it. One engineer throttles load. Output dips. Hardware survives. Lesson learned. More panel area wins. That is how systems mature. Fail small, fix fast. Power is the other side. Earth solar loses energy in air and clouds. In orbit, sunlight is steadier. Sun-synchronous paths keep panels lit longer. That cuts battery needs. Batteries are heavy. Batteries wear out. Fewer batteries mean more compute per launch. That is resource efficiency you can count. Now bring in data. Compute without data is useless. The merger brings models and live data. The platform adds a live fire hose. Starlink moves that data. Optical links between satellites keep traffic off the ground until needed. That cuts delay. It also spreads load. This is not just faster, it is more robust. Here is the pattern you've seen before. First example, vertical control beats partnerships. Second example, scale beats elegance. Third example, owning infrastructure beats renting it. SpaceX checks all three. That pattern explains why SpaceX came first. Tesla did not absorb XAI. Neuralink did not. SpaceX did. Tesla's role still matters. Tesla put about $2 billion into XAI. Tesla shares tech, especially for Optimus. That helps models train on real-world tasks. But Tesla is not the hub. SpaceX is. Space hosts the power solution. Space hosts the cooling solution. Control implications flow from that. SpaceX becomes the umbrella. The other companies sit inside or stay as layers. Specialized, valuable, not central. That hierarchy matters. It sets who dictates timelines. It sets who allocates capital. It sets who wins conflicts. This matters more than it sounds. AI growth is hitting walls. Power permits stall projects. Cooling fights break out. If SpaceX bypasses those fights, it gains speed. Speed compounds. Competitors stuck on Earth wait years. SpaceX launches in months. That gap widens. Now the competitive scoreboard appears. The claim is that space AI compute can be the lowest cost option in 5 years. Others doubt it. Doubt is normal. The metric will be cost per compute hour. Launch rate drives that. If Starship flies often, cost drops. If it slips, the plan slips. Timeline matters. The merge happened in February 2026. That lines up with Starship nearing regular flights. Post-2026 is the window. If reusability holds, scale follows. If scale follows, orbit compute becomes real. This is not guesswork. It is cause and effect. Financially, the IPO angle is clear. A $1 trillion target pulls capital. Capital funds scale. Scale feeds launch cadence. Cadence drops cost. Cost attracts customers. Customers feed models. Models drive demand. It is a loop. SpaceX sits at the center of it. Justice through consequences shows up quietly. Firms that rely on grids wait. Firms that fight permits stall. Firms that need water face limits. Space-based systems avoid those traps. The consequence is faster growth, not because of hype, because of physics. Now project forward. If Orbit AI works, it changes cloud computing. Some workloads move off Earth. Power-heavy training shifts first. Cooling-heavy tasks follow. Earth data centers focus on edge and storage. Space handles brute force compute. That split makes sense. Competitors will try to respond. They need heavy lift. They need networks. They need solar and cooling designs. Missing any slows them. Catching up takes years. Meanwhile, SpaceX compounds. This is not about one company winning everything. It is about removing the main limits. Power and heat stopped AI growth before. Space offers a path around them. SpaceX owns the path. That is why the move went there first. The merge signals dominance through control, not noise. Rockets, satellites, AI, data, and leadership now align. Each supports the other. That alignment is rare. It is also hard to copy. The ending is simple. SpaceX positioned itself as the core. The models plug in. Growth shifts upward. If the plan works, AI scale stops fighting Earth. It starts using space. The scoreboard will show it soon.